So here for section 3.1, we're going to start off with our very basic statements that we'll look at in all of our sections and use for truth tables and lots of other things. But a statement is a sentence. It's either true or false. It can't be this both simultaneously. And we always represent them with lowercase letters such as P, Q, R, and S. And again, it doesn't have to be true or false. It can be true or false. It can't be both at the same time. So our first statement here, we have statement P, where Bel Air is in Harford County. Q is 6 times 7 equals 42. And this is a statement because it is a sentence, because it has that equal sign in there, and that is a verb in math, which makes it a sentence. And then we also have Maryland is not part of the United States. Again, that's a false statement, but it's still a statement. So here they're talking about negating a statement, and to negate a statement, you either put the word not into the statement or take the word not out of the statement. The negation of a true statement is a false statement, and the negation of a false statement is a true statement. So it's the opposite of what it was. The symbol that we use is I call it the wave. You can see it right here, and there's another example. So here what we're going to do is practice writing things symbolically, or if it's in symbols, to write it in words. So we have two statements here. P is Rome is the capital of France. Q is Thursday is the day of the week. So for A, they want us to express Rome is not the capital of France. Now, if you look up at P, it is Rome is the capital of France. Since we have Rome is not the capital of France, that is the negation of P. So if we write it in symbols, we'd write our little wave and then P. B says to write the symbolic statement in words. So we have the negation of Q here. Q is Thursday is the day of the week. So the negation of that would be Thursday is not a day of the week. So you don't really change the statement other than placing the word not into the statement. Okay, so here we're looking at quantified statements. And quantified statements are statements that contain the words all, some, and no, or none. So what they want us to do is express the quantified statement in an equivalent way. So that means that it's going to be, a statement that is equivalent to the original one. And then also write the negation of the statement. So for the first one, all whales are mammals. If you look back at the PowerPoint, the equivalent way to express all whales are mammals is there, and I apologize again for the writing, are no, and it's A that are not B, but our A is there are no whales that are not mammals. So that is the equivalent way to express it. Now the negation of this statement is going to be some whales are not mammals. And here I want you to you're going to see a pattern. So all, when you negate it, goes to some are not. Okay. All right, our next one we have is some business majors or some students are business majors. Now, the equivalent way to express this statement is there, and you want to do it just like they do it, exactly like this. So there exists at least one student that is a business major. So that's the equivalent way. So it's the same thing as some students are business majors. Now, to negate the statement, instead of some A are B, you are going to say no students are business majors. Okay, next we have some band members are not keyboard players. So we're going to start off the equivalent way to express this would be not all band members are keyboard players. And then to negate it, instead of some are not, you're going to go with all. And this is, again, the negation. All band members are keyboard players. So the all and some are not are like converses of each other or inverses. Okay. Then we have no dogs are cats. So that's our no statement. And the equivalent way to write this would be all dogs are not cats. So that's the equivalent way to write it. And then the negation would be some dogs are cats. And if you'll notice with the no and the some are, they are how we write the negation. So no A R B, when you negate it, is some are. And if we go up to our some are, when we had that and we negated it, it was no. So again, if you remember that these two go together, I'm going to put them in blue, these two go together for negations, and then these two, it kind of helps you to remember how to negate the statements. Okay, so here we're working in section 3.2, and we're going to start looking at compound statements and connectives. So we've talked about simple statements so far, but if you put two or more simple statements together, they form a compound statement, and your compound statements are going to be conjoined by connectives such as and, or, and if then. We're going to start with our first connector, and that is the word and that is called a conjunction. The symbol that you use for and, it's an upside down V. And this statement, when we put it on a truth table, or we look at two statements, it is true if both statements, so both P and Q, are true. So here I have P is I'm leaving, Q is you're staying. And they want me to express each compound statement in symbols. So my first statement says I'm leaving and you're staying. I'm leaving is statement P, so we have P, and then we have the keyword here and, so we're going to put our upside down V. You're staying is Q. So that's how I would write the first one in symbols. The next one, I'm going to move it out over here so I have space. It says you're staying and I'm not leaving. If we go back and we look, you're staying is Q, so we'll start with that. We have the keyword and, so I'm going to put my upside down V. And then it says I'm not leaving. I'm leaving is P, because I'm not leaving is the negation. We'll put the negation of P there. So here we have a disjunction, which is using the connector of or. The symbol looks like a capital V. And our or statements are true unless both P and Q are false. So if both statements are false, then the whole thing is false. But otherwise, if you have at least one true, the statement is true. So our two statements they gave us is P is I study and Q is I pass the course. And they want us to write the two statements below symbolically. So our first one says I pass the course or I study. I pass the course is Q, so we'll put that first, or will give us our V, and then I study is P. Next we have I do not study or I do not pass the course. Since P is I study, I do not study will be the negation of P, or will be my V, and then I do not pass the course is the negation of Q. Okay, so here, our next connector is a conditional statement, and this is our if P, then Q. So P is the hypothesis or the antecedent, and Q is the conclusion or the consequent. The symbol that we use is an arrow, and it's going to be pointing to the right. And this one I think is the hardest on a truth table. It is true unless P, or the hypothesis, is true and Q is false. So if the first part is true and the second part is false, it's a false statement. Otherwise, it is true. And we'll look at that later on a truth table. Sometimes your if statement is called the sufficient condition and the then is called the necessary condition. Again, we're going to write some statements symbolically. So our P statement is this is an alligator. Q is this is a reptile. So for our first one, it says if this is an alligator, then this is a reptile. So if P, then Q for the first one. Number 2 says if this is not a reptile, so that would be the negation of Q, then it is not an alligator. So again, it's a conditional statement. We'll put that arrow in there. And not an alligator will be the negation of P. For number 3, it is if this is a reptile, then this is an alligator. So this is a reptile is Q. We'll put our arrow, and then this is an alligator will be P. And the last connector that we're going to be looking at is the biconditional statement. And this is our if and only if statement. So it's P if and only if Q. So the symbol here we use is a double-sided arrow between the two statements. And it is true when both P and Q are true or they are both false. So both statements have to be the same thing for it to be a true statement. Again, we're going to write them symbolically. We have P is the campus is closed and Q is it is Sunday. So our first statement says the campus is closed if and only if it is Sunday. So the campus is closed is P. Because we have the if and only if, we'll put the double-sided arrow. It is Sunday is Q. Next, we have the campus is not closed if and only if it is not Sunday. So the campus is not closed will be the negation of P. We'll put our double-sided arrow. And then it is not Sunday would be the negation of Q. And then our last one here is the campus being closed is necessary and sufficient for being Sunday. Remember, necessary and sufficient is the same as our if and only if. So the campus being closed will be P, and we'll put our double-sided arrow, is necessary and sufficient for it being Sunday. So that's going to be Q. All right, here, so far we've been mainly taking statements and putting them into symbols. But now we're going to take our symbols and put them into statements. So they give us the simple statements, and P is the heater is working, Q is the house is cold. So they want me to take the symbols here and to put it into words. So the first thing we know is we have the negation of P. So P is the heater is working. Not P would be the heater is not working. And then this, remember, is the symbol for and. And then is Q, the house is cold. All right, our next one. Now we have P. So it's going to be the heater is working. Or is our symbol for or. And then the negation of Q, the house is not cold. All right, for our third one, here we have a conditional statement because we have that single-sided arrow there. So we're going to start off with if, and then we're going to put, because it's our if-then statement, we're going to put Q in there. So if the house is cold, then, and it's the negation of P, the heater is not working. And then our last one, we have our biconditional statement. So it's our if and only if. So we're going to start off with P. So the heater is working. If and only if the house is not cold, because it's the negation of Q. So here we're going to look at symbolic statements with parentheses. And really what we're going to look at is the negation of an entire statement. So if you have the negation symbol outside your parentheses, that means you're negating the entire statement. So what you would do is if the negation symbol is outside the parentheses, you start the statement off with, it is so it would be, it is not true that, and then you're going to put the statement that's inside the parentheses. So it would be here in our case, P is Romeo loves Juliet. And, because that's our and symbol, Juliet loves Romeo. So again, if the negation is on the outside of the parentheses, you start off with, it is not true that, and then you just put the statement that's in the parentheses. Now the second one is different because we're not negating the whole statement, we're just negating P here because it's not in parentheses. So that would be the statement, the whole statement would be Romeo does not love Juliet, and Juliet loves Romeo, because we're not negating Q. Okay, and then our last one, again, we're negating the whole thing because the negation is outside the parentheses, so we would start off with, it is not true that, And then we're going to do Romeo loves Juliet. Or, because that's our or symbol, Juliet loves Romeo. Okay, so here we are working with 3 statements. P is the temperature is above 85 degrees. Q is we finish studying. And R is we go to the beach. So when we do this one, for the first one, it's an if-then statement. The main one is an if-then statement. So our if portion is the if P, it'll be the P and Q, and then our then portion is the R. So when we write it, we're going to start off with if the temperature is above 85 degrees and we finish studying, then we go to the beach. Our next one is the first part. We have a biconditional statement. So it is P if and only if Q. So we can say the temperature, which I'm going to abbreviate temp, is above 85 degrees if and only if we finish studying and then we have an and we go to the beach. And then our last one, we're going to start with R. So it is we go to the beach. If and only if we finish studying and the temperature is above 85 degrees. So the next few slides are going to look at truth tables for all 4 of our connectors that we've seen so far. So remember, we're just going to review the symbols to help us with them on the truth table. Remember, we have our conjunction, which our symbol is the upside down V, and it means and. And it is true when both P and Q are true. So both statements have to be true in order for the and statement to be true, otherwise it's false. Then we have our or statement, which is the V, and that's our or, and it is true unless both P and Q are false. Then we have our arrow, which is the if-then statement. It's our conditional. And it is true unless P, or the hypothesis, the first part, is true and Q, or the second part, the conclusion, is false. And then our last one is our biconditional. It's our if and only if. And remember, it is true when both P and Q are both true or they're both false. So the symbols have to be the same. Okay, so the first truth table that I think we're going to do is we're going to do the negation of P and Q. So if I ask you for a truth table to give me the truth values for this statement, we're going to create a truth table. So what we're going to do is all of our truth tables are always going to start off the same way. We're going to look at just P and Q by themselves. So we have P and Q. P will always be true, true, false, false. And then Q will always be true, false, and true, false. And we're just always going to start them off that way. Really what we're doing here is we're looking at the different outcomes that we could have for our two statements. And these are the 4 different outcomes. So we could have P be true and Q be true, or P could be true and Q could be false, or P could be false, Q could be true, or P and Q could both be false. Now, to finish off our truth table, we have 2 parts to this statement. So we have the negation of P, so we're going to put that there. And then what we're going to do is our last column will be the negation of P and Q. So we'll put the whole thing together. To do the negation of P, it's going to be the opposite of your P column. So where we have the 2 trues, the negation, remember, makes it the opposite. So it'll make it 2 falses. So it'll be false, false. And where we have the 2 falses, it becomes true, true. Okay. Now, for this last column, we are doing the negation of P. So I have to look at this column and Q. So to get this 3rd column right here, I have to look at these 2 columns together. And it's an and statement. Remember, and is true if both statements are true. So if I look here, if I go across and I look at the first one, I have true, false. So that's going to make that statement false because they're not both true. Then I have false, false here. They're both false, so that's going to make it false. My 3rd row across, I have true, true. So that makes that and statement true. So that spot will have a T. And then the last one, it's false, true. So that's going to make it false as well. So that's our first truth table we've done. Let's take a look at the negation of the entire statement of P or Q. Okay, so here, when I make this statement, again, I'm always going to start off with P and Q on my truth table. And it's always going to, P will always be true, true. And then false, false. Q will always be true, false. And then true, false. Okay, so for this one, I want to negate P or Q. But before I can negate that, I need to know what P or Q would be. So we're going to put P or Q on our truth table. And then we'll put the negation of P or Q. So remember, an or statement is true unless both P and Q are false. So if I look across here, for my first one, I have true, true. So that makes that statement true. I have a true, false. So that's going to be true because it's true unless both are false. So I didn't have 2 falses there, only one. And here I have false, true. So that's going to make that true. But at the bottom, when I have my two falses, that's where I get my false statement. Okay, so again, I looked at P and Q to get my OR column. Now, for the fourth column, we're negating this statement right here. So I already have P or Q. If you negate it, remember, it's just the opposite of what it was. So if it's true, it becomes false. So my first three statements in that column will be false. And then my last one, which was false, will become true. Okay, next we're going to look at the negation of P or not Q. Okay, so again, always start your truth table with P and Q. P is always true, true, false, false, and Q is true, false, true, false. Okay, so now for the parts of my statement, I need to do the parentheses first, like look at that. And I already have P on my truth table, but I need the negation of Q. So I'm going to add that column in. Okay. Then once I put the negation of Q in, I can do P or not Q, because I need to look at the statement on the inside of the parentheses before I can do the negation of the entire statement, because I need to know what this P or not Q is equal to. Okay, so remember, negation of Q is the opposite of Q. So it's going to be false, true, false, true. And then we have P or not Q. So to get that column, I'm going to look at P and not Q. Remember, it's an OR column, so it is true unless they are both false. So if I look at the first one, I have a true false, so that makes it true. I have true true, so that's going to be a true column. Then the third row across is false false, so that makes that a false statement. And then I have false true, so that makes it a true statement. And then remember, the last column here, we're negating this statement, so it's going to be the opposite of whatever we put in this column. So it's going to be false, false, true, false. Okay, let's look at a biconditional statement next. So we're going to do P if and only if Q. So I want to put that on a truth table. So again, we're always going to start off with our P and Q. So we'll have true, true, false, false, and then we'll have true, false, true, false. And we only need one more column here because we need just the biconditional. So P if and only if Q. And remember, your biconditional, your if and only if, is true when both statements are either both true or both statements are either false. So for the first row here, I have two trues, so that makes it a true statement. The second one, I have a true and a false, so because they're different, it makes it false. Here, again, they're different, so it's false. But then on my last one, there's two false statements, so that makes it true. Let's also look at a conditional statement. So let's do if not Q, then not P. So if I put that one on a truth table, again, we always start off with P and Q. And we're going to have true, true, false, false, true, false, true, false. And then I need, for my conditional, I need not Q and not P. So I'm going to put not Q on there and not P, or the negation of both. So the negation of Q would be false, true, false, true. And the negation of P will be false, false, true, true. And then now that I have both of these columns, I can do my last one, which is what I really need, the negation, if the negation of Q, then the negation of P. And this is one where it's a little bit harder because it's a conditional statement. You have to look at the order. So remember, this one is, it is true unless the first part of the hypothesis is true and the second part is false. And I always say look at it in alphabetical order. So if we go from T to F, that is not alphabetical order. It makes it a false statement. Otherwise, if we look here, I have false, false. It's the same letter, so it is a true statement. It is in alphabetical order. Here I go again. I have true and then false. It's not alphabetical order, so that makes it a false statement. Here, though, I have false and then true. Alphabetical order, so it's true, and then true, true is also true. So that one, order does matter, and you want to look at what's the first statement, what's the second statement. Make sure you follow it carefully. Okay, we're going to do one more truth table, and let's do the negation of P and not Q, or P if and only if Q. Okay, so that one, it has a lot of parts to it. We're going to have a lot of parts on our truth table. Again, we're always going to start off with our P and our Q. Okay, and then I know that I also need the negation of Q, because I need that in one of my parts. Okay, so now I have all the single letters that I need. So next, I'm going to put on here P and not Q, because I need that statement so that I can then negate that whole statement. And then I need P if and only if Q, so that then I can take it, and my last column will be where I put everything together. I'll do the negation of P and not Q, or P if and only if Q. Okay, so let's work on this. P is always going to be true, true, false, false. Q will be true, false, true, false. The negation of Q is the opposite of the Q column, so it will be false, true, false, true. All right, then we have P and not Q. So for that one, I need to look at my P column and not Q. And it's an and, so it is true when they're both true. So for the first one, I have true, false, so that makes it false. Then I have my true, true, so I get my true there. Then I have false, false, so that's false. And then false, true would make that false. Now remember, to get the negation of that statement, we just do the opposite of this column right here. So it's going to be true, false, true, true. And then my biconditional statement, remember, it is true when both P and Q are true or both false. So, and because it deals with P and Q, I'm going to go with black now. I need to go all the way back to my P and Q original columns. So like here, I have two trues, so that makes that statement true. Here it is true, false, so that makes it false because they're different. False, true is false, and then false, false would be true. And then my final column, I put everything together. But really what I'm doing here is I'm taking and putting this statement with this statement as an or. So remember, your or is true unless they're both false. So if I go across here, and look, I have true, true, so that makes it true. False, false, they're both false, so that's false. Then we have true, false, so that's true, and true, true makes it true. So that's our final column, and our truth table is done. So here we're looking at De Morgan's laws to write a statement that is equivalent to the statement we're given. And if you recall from the PowerPoint, De Morgan's laws state that if we are negating the entire statement of P and Q, that statement is equivalent, and that's why they have the 3 lines, because it means equivalent, to the negation of P or the negation of Q. So you separate them out. And then it is the same if you do the negation of the entire statement of P or Q. That is equivalent to the negation of P and the negation of Q. So it's kind of like you distribute that negation symbol and flip your and or. So here it says, it is not true that Australia and China are both islands. This, it is not true that, remember that's the negation of, and then it's P and Q. So to write it in an equivalent form, we're going to say Australia Sorry, that A looks a little crazy. Let me fix that. So we're going to say Australia is not an island, or China is not an island. All right, for the second one, it's already in symbols, so we're just going to write it. We don't know what the statements are, so we're going to write it in symbols as well. So here, they're negating this whole statement, and then you want to do the opposite on the inside. So they negated P, so our equivalent statement would be P. It was and, so we're going to change it to or, and then it was Q, so we're going to negate Q. So it would be P or not Q. And then our last one, it is not true that the movie is interesting or entertaining. So that would be P and that would be Q. And it's an or statement. So we're going to say the movie is not interesting and not entertaining. All right, and the last thing we're going to do is take a look at an argument and determine if the argument is valid or not. So there's 3 steps that you have to go through if you look at the PowerPoint. The first one is you have to symbolize each premise and the conclusion. Your argument is going to be made up of 2 premises, so the first 2 lines, and then your conclusion. And you'll know the conclusion because it'll have the therefore, or the symbol for therefore are 3 dots in the shape of a triangle. So we want to symbolize that. So we're going to start off with, if you are a hound dog, then you howl at the moon. So you are a hound dog is going to be P. You howl at the moon is Q. So you're always going to assume, like the first statement is P, the second one is Q, unless they tell you differently. And it's an if-then statement. So we're going to have, for the first one, if P, then Q. The second line says you don't howl at the moon. You howl at the moon is Q, so you don't howl at the moon would be the negation of Q. And then we have our conclusion. Again, those 3 dots mean therefore you aren't a hound dog would be the negation of P. Okay, so next we're going to make a truth table for our argument, and we want all the pieces of our argument on the truth table. So we're going to start off with P and Q, and it'll be true, true, false, false, and then we'll have true, false, true, false. Then my first argument or premise is if P, then Q. Then I have the negation of Q and the negation of P. And if you can put them in order, it really does help you at the end when you're trying to determine if it's valid or not. So our conditional statement is true unless the hypothesis or the first part is true and the second part is false. So remember that alphabetical order. Here, true, true is going to be a true statement. True, false, that's our false statement because it's not alphabetical order. Then we have false, true, that's true, and false, false is true. The negation of Q will be false, true, false, true, and the negation of P will be false, false, true, true. Now, the last thing you want to do is you want to determine if your argument is valid or not. To determine if your argument is valid, what you have to do is you have to look at your conclusion column, which here's my conclusion, here's a premise, here's a premise. And the only rows you have to look at in your conclusion column are where you have a false answer. And if you have a false conclusion, but every premise, so both of the premises are true, then your argument is invalid. Otherwise, it's a valid argument. Just think of it this way, 2 rights don't make a wrong. So these, if it's a true conclusion, I don't have to worry about it to determine if it's valid or not. But here, I have true, false, so that's okay. And I have false, true, so that's okay. So that makes it a valid argument. It would be invalid if, and I'm just going to write this up here, if I had a premise, and conclusion. And you're looking at your truth table. And if you have true, true, and your conclusion is false, so both premises are true and the conclusion's false, and it only takes 1 row of this in your argument to make the entire argument invalid. If this happens, the argument is invalid.